How are you doing this morning?
Well, actually, it's afternoon here. Did you get my email? Because I've sent you two articles.
Yes, I looked over those.
Okay, wonderful. So how should we proceed, or how should we do the whole thing?
Well, I would like to start at the beginning of contour crafting a long time ago.
Right. Yeah, that's true. Okay, sure. Should we start right now, or should we discuss some agenda points before we do that, or how do you usually handle it?
We can talk about what we will talk about. I guess I'll ask about the origin of the company and then a little bit about the future vision for the company. And we can really go into anything in between.
All right. Well, let's see. I mean, as you've rightfully mentioned already, contour crafting is well, actually the pioneer in the sector, because Professor Krishnevas was publishing the concept of contour crafting as early as 1994. I think in '96 the first patents were issued or filed, actually, for patents, and so it's been a long time. But most of that time, of course, was during the university phase, right? But we can certainly start there. There's a mismatch, if you will, between my role and the start of contour crafting, because contour crafting was invented and first published in 1994 by Professor Barry Krishnevas, who is also the later founder of Contour Crafting Corporation. So at the time when he was publishing the concept of contour crafting, which is roughly a concept of combining 3D large-scale construction printing with automation, meaning that basically contour crafting is a fusion of technologies, a robotic, actually a robotic solution or vision actually at the time. So you can visualize that thing, but basically a building while it rises being printed. Everything else is automatically brought into the structure, regardless whether it is rebar, whether it is piping, wiring, flooring, tiling, whatever. So that was actually the concept. Of course, then in 1994, it was a sheer vision, of course, of Professor Barry Krishnevas. But relatively soon, it was followed by the first patents in 1996. Meanwhile, the company is holding over 100 national and international patents in this field, actually, or basically in the field of 3D printing, but mainly, predominantly in 3D construction printing, actually. Professor Krishnevas used to be, or still is, I guess, the director of CRAFT at USC. CRAFT is an abbreviation which stands for Center of Rapid Manufacturing Technologies. And one of them actually was contour crafting, basically. And later on in 2014, officially, Contour Crafting Corporation was established by him as a corporation, because everything before that was actually happening strictly at USC, right? And therefore, from this time, all the patents which exist or existed meanwhile, because it's a 20-year maximum time span, as you know, for patents. Some of them have expired, of course, meanwhile. But all patents which are alive today are exclusively licensed from USC to Contour Crafting Corporation. Plus, of course, meanwhile, Contour Crafting Corporation has filed a number of additional patents. So formally, the company was established in 2014. If I'm not mistaken, in fall 2015, I made contact with Barry Krishnevas. So that was basically the initial phase of our relationship. And actually, it started out like probably in so many other cases by an email. I sent an email to him because I saw his TED appearance, and that raised my interest in the whole technology and concept. And then our relationship became more and more intense. In January 2016, we met in Vienna by a coincidence, actually. And when I joined my later company, Group, later in May 2016, we started talks in June 2016 regarding a possible investment of my company in Contour Crafting Corporation. And that led basically to a due diligence, and the due diligence was successfully closed in May 2017. So it almost took a year. But that is not unusual because, you know, we had a European Austrian company on one side and a US company on the other hand. We had 9 hours of time difference. So 2 different legal systems and also a startup company. So it took a while to get everything we needed, to have a look on everything we needed before we had this closing. But it was the start of a wonderful official relationship. And of course, the money that was one of the many impacts of the investment enabled Contour Crafting Corporation to start as a real full-fledged company. And that, of course, was a very significant change to the better, actually, because then things shifted from a strictly university environment to the start of a corporation. And I think very wisely we chose, and we're lucky to get a very spacious company, a space. We rented, we're still renting a large enterprise on, well, actually a warehouse plus many offices in El Segundo, which is a part of Greater Los Angeles. And that provided the space for not only R&D activities, but also for production and manufacturing to some scale, right? And of course, it allowed for staffing the company, predominantly with R&D personnel at the beginning, but over time, of course, with other key personnel.
Does Contour Crafting disclose how much capital they've raised to date?
No.
So you are an investor as of 2017?
Correct, yes. Well, actually, I have to say that I'm not working for the companies as of recently. So it's a historic look back, more or less, but it's pretty recent. And until the end of November, I served as the chairman of the board of directors of this company. And due to my very intense friendship and relationship with Barry Krishnavis, as of now, I'm acting as his personal advisor, if you will. So I'm still speaking on behalf of the company because also Barack wanted that I would give this interview instead of him.
So I'm looking at the company that you were CEO of. How do you pronounce it?
Umdash Group, yeah.
Umdash.
Well, actually, the Umdash Group is a holding company, and it consists of 3 divisions. 2 of them are historic, traditional. The largest one being Doka, which is one of the 2 world market leaders in formwork engineering. The second one is Umdash the Store Makers, which is a leading company in store making. And Umdash Group Ventures is the 3rd division. And actually, I was co-founding this division and heading it as CEO later on. And this division has only new technologies and new business models within its scope, right? So it's a strategic entity.
And how many different ventures have they invested in?
Well, you know, the setup of Umdash Group Ventures is very unique because it is not a classic portfolio investment group. or company. It's actually a combination of 100% own developments, which lead to the formation of classic business units, if you want. As of now, we have two of them. The first is called Neuland, which is a revolutionary new mobile precast plant type, highly productive. The second division is called Contact, where the business model is basically, and the technology is basically the digitalization of construction sites. As of now, poured concrete construction sites, but over the time, also other construction technologies will be covered by the technology in order to provide transparency, data, information to this sector, which is, as we speak, dramatically under-digitalized in comparison to classic manufacturing sectors. This is the first part, basically. The other part is what you just referred to, is strategic investments in technology companies. As of now, Umderschrift Ventures has 3 strategic investments. Contour Crafting Corporation being the biggest, the oldest one, actually. As I said already, the closing was in May 2017. The second was a prop tech company, where we acquired UTV, or Umderschrift Ventures acquired 30% in Contour Crafting Corporation. The other investment was a prop tech company by the name of NeoTwin. Here, a majority share of 51% was acquired, and the latest investment was last year in 2020, when a 26% stake was acquired in May last year. That was the first investment in a retail-related environment.
That's very cool. Some people would say it's risky to try to do so many different things, but it seems to me like it decreases the risk, because if you're involved in so many different kind of cutting edge projects, then only one really needs to be dramatically successful for the whole thing to work out. But they all seem like things that the world needs, and the world is needing at an increasing rate, especially concrete. Have you been paying any attention to lumber prices?
No.
I've noticed they've been skyrocketing in America. I'm not sure if that's the same in your region.
Oh, is it right? Yeah. Well, probably. I'm not that linked to this topic, I have to admit, because so far we have, or I personally also have focused more in concrete.
That could be very good news.
Related to concrete, which actually brings me already to a very important and undervalued topic, I think, in the connection with 3D construction printing, because everybody who is active in this sector as of now is claiming or stating that they are printing concrete, which is actually not fully correct, because to my knowledge, everybody except Contour Crafting is printing with cementitious material, yes, but certainly not concrete, because concrete contains coarse aggregates, right? Which is, among other things, of course. Why is this important? I think, or at least we believe, and I personally believe, I'm fully convinced that this is a very important thing, because obviously construction is a large, high volume business. So it is not irrelevant what your material is costing, right? And as we all know, concrete is a worldwide available, relatively inexpensive resource. And therefore, this, of course, is the benchmark for all other possible technologies. And if one claims that they're printing with concrete, of course, the price of the material and the comparison between the prices is one of the most significant factors in such a business model. What I witnessed so far was that the majority is actually printing with special mortars. What I've learned so far, here and there, you get some information, of course, from parties involved or direct information. That's the manifold price of concrete. In many cases, I learned that it's between 3 times, 5 times, I think in one rare case, up to 10 times more expensive than concrete. So this is one issue, right? Because at the end of the day, technology or a new technological approach, of course, can be very thrilling, compelling at the very beginning. But at the end of the day, everything boils down to the triangle of quality and cost. And time, of course, right? Because each new or potentially new construction method is naturally at some point, at least, in direct competition with all other established construction technologies. So therefore, the cost of the material that is printed is one very major factor. And that's the reason actually why Contour Crafting Corporation, right after the closing in May 2017, I think in August we made the strategic decision that we need to find a way to be able to really print with concrete. Because before that, also Contour Crafting Corporation or Contour Crafting has been printing with mortars. Why? Because it is very tempting. It's easy. You know, it's a toothpaste-like material, very easy to process, to pump. But if you really want to process concrete, especially in a combination with a digitalized, very highly robotic, highly precise function and process, this is all but trivial. And also, it took Contour Crafting Corporation much longer than we have hoped it would take to achieve the point where we really can justified say that Contour Crafting Corporation is able to really print with concrete. And this includes coarse aggregates up to a grain size of 12 millimeters, which is a significant grain size.
I've heard from a few sources that companies are now looking for a material that would occupy less than 1% of the percentage by weight of the concrete, and it would make any typical concrete mixture printable. There's maybe 3 materials that might fill that need. One of them maybe carbon fiber.
Carbon fiber typically is pretty expensive.
Yeah, I heard somebody reached out to me on LinkedIn and said they could get carbon fiber at scale for 10 cents a gram.
Well, let's wait and see. We've made our experiences with fiber, with carbon fibers as well, in order to print concrete in a combination, fiber concrete, if you will. We have tested with carbon fiber and also with steel fibers. We preferred steel fiber for cost factors, of course.
So when you're trying to increase the tension strength of concrete, any wire needs to be in tension, and my understanding, if you want to prevent cracking. Otherwise, if it's not in tension, you're just holding it together after the crack. So,
well, I mean, the whole question is what does it need and what does it take in the area where you want to build? You know, as you know, Los Angeles especially is a very highly seismological active zone with the highest demand regarding structural integrity. Of course, on the surface of the Earth, we have different conditions, right? We have large areas where there is practically no seismic activity. That's one factor, what determines what material you need and what structural support this material will potentially need. On the other hand, there are, of course, other areas where there is increased or very high seismic activity. And of course, then you need rebar and you need a proven material. That's actually another reason why we focused on concrete, because concrete is known to the authorities. Everybody knows about concrete. So that's been tested, it's proven. It's a a very good way to build structures. Another aspect regarding concrete, and you mentioned that a lot of people also are occupied with finding alternative materials. I'm a little bit skeptical to that. However, the idea is of course very good, and it's all needed. What actually is needed is to reduce the CO2 footprint. The concrete and the cement industry has been given a bad name recently because of CO2, which is, in my opinion, overstated and exaggerated, because if you really look in the industry and make fair apples to apples and peers to peers comparisons, it's not really that bad. However, concrete is really unbeatable. So I think the real task, and many people are working on it, is to reduce the amount of cement in concrete, in traditional concrete already. And here is another negative example if one is printing with mortar, because mortars typically have a much higher cement content than regular concrete, right? So this is another reason why we focused successfully on printing with concretes.
Mm-hmm. When you're printing, how often do you need an expansion joint? I don't see many expansion joints on some of the 3D printed buildings I've visited.
Well, there is another difference between contour crafting so far and other companies. We have actually not focused on printing whole buildings and structures, because this has been done almost decades ago at the USC time, so to say. What we have been focusing on was basically, maybe you have this information also received, is that in I think it was in June 2019, the acceptance criteria 509 was authorized by the ICC. And this was actually the result of a cooperation between Contour Crafting Corporation and ICC. And the ICC in AC 509 has a number of very, very specific tests, which is basically the foundation of another very, very important aspect of the sector, is getting regular building permits, right? Because if you want to build anything in any country in the world, everything is based on existing building codes. So 3D construction printing is a new technology. It's not part of any established building code wherever in the world. So, and that's the reason why everything that has been printed so far was either printed in a university setting or on a territory or a land that has a special how can I say, a status, like a test field or something that is definitely
not for profit or something like that.
Hmm?
Or not for profit, or it's just
right. But the name of the game, of course, and in order to be able to open up a regular business, is of course that contour crafting or 3D construction printing needs to be a part of a standard regular building code. And therefore contour crafting was aiming at that direction and has been successful so far, very much by achieving this AC 509. And of course, AC 509 is not a stationary acceptance criteria. It can be enlarged because right now it's only on one regarding one-story buildings, but of course this will be increased over time. But here the focus is on special, on certain dimensions of walls, wall types, T-junctions, and other stuff, So this has been in the focus in the past years, and not printing buildings, because that has been done earlier.
Mm-hmm. A lot of companies are developing different apparatuses to print buildings. Most of them are ignoring the permitting and just kind of thinking that's someone else's problem. It's good that companies actively pursuing.
But In fact, it's not, right? Because of course one can say, well, I'm technology provider and the rest is your problem, dear customer. But this is not really, in my opinion, a very smart move because as I said, as of now, of course it is possible to get single case permits, but this is a very laborious, costly, and time consuming process versus going to any authority in the world saying, okay, I want to print this building, and everybody says, okay, wonderful, we have a building code in place for that, let's take it off.
So the CraftTrans system,
because once the industry has not, or as long as the industry has not yet reached such a state, to be honest, there is no market. It's only single case to single case to single case.
Yeah, it needs to demonstrate significant cost reduction or time reduction or quality improvement, like you mentioned. And it very obviously hasn't reached a wide scale yet.
Yeah, I mean, we really have to say that this technology is still in a relatively early stage, right? Mm-hmm. And like in any other meanwhile established technologies, all of them had such an early phase, right? We all remember, I don't know your age, but looking or remembering the first mobile phones, you know, they were like I don't know, they were looking like a shoebox, you know, and they were heavy and very inefficient and extremely expensive. Now everybody has a smartphone for a fraction of the price. With 100 times more functionalities and so on. So this has happened to each and every technology. But I think a couple of things can be guessed from the very beginning. And if we look and see what is happening globally under the headline of 3D construction printing, sometimes I'm asking myself, how was this approach ever started? Because it should have been clear from the very beginning, this could not work, at least not economically, right? Of course, it is a possibility to provide a technology or a technological approach where everybody says, oh, wow, have you seen this? This is the first time. Yeah, okay. But in the end of the day, when business people meet, you know, the question is, what did it cost? How long did it take you? What is the quality? So what is the total cost of ownership? Because at the end of the day, this is what decides whether you have a business or whether it is happy engineering.
Mm-hmm. It could be unprofitable until a certain point when it reaches economies of scale. And so there's kind of lost leaders potentially.
Yes, I agree. But, and that's the reason why Contour Crafting Corporation is really taking one step after the other, because we have done so many things historically already that we know all the pain points. Mm-hmm. And another reason why Contour Crafting Corporation is very traditional, well, a little bit reluctant when it comes to providing information, is because especially Professor Krishnavis has made repeatedly the experience that whenever he has shown something or provided information, everybody jumped on it and tried to copy it. And therefore, we are a little bit reluctant and keep much more to ourselves than others, because we don't need a Series B round or anything else in order to make us more attractive, you know. And the classic way to make yourself more attractive is to communicate, right?
Yeah, I appreciate that. The typical A round, B round, C round funding, they raise so much money. It concerns me they may be more focused on raising more money than the engineering and the technology sometimes.
Yeah, absolutely. I share your impression, especially as a European, because if you look at the company valuations, especially startup valuations, and the numbers that are, you know, shared in public, I think they're generally much overstated. And I always ask myself, when can that be earned back? You know, how many centuries will it take in order to earn back all this invested money? And also, typically we Europeans are much more conservative regarding company valuations.
Mm-hmm.
I think what you need is a very sound technological basis. And of course, you need the money, because without money, nothing is going to happen, of course, right? But I think it has to be a very balanced approach between really down-to-earth concepts and technologies, and of course, a sound financing of the company. And I'm very happy to have Barak Kushnevis, because he's really a genius. It's every time I'm so impressed whenever a problem pops up. It's really amazing. It's really amazing.
Let's try a thought experiment. What
Mm-hmm.
happens if the material cost for 3D printed concrete becomes the same cost as typical concrete?
Well, this is exactly what contour crafting is aiming at. I think right now it is not already parity, but it's relatively close to parity. But this is a galaxy apart from 3 times, 5 times, or 10 times if you have special mortars, of course, right? So I don't think that there is a long way to go that way. However, it's not only the material, of course, and that's another reason why everything Contour Crafting Corporation has designed and published so far, and we have only published the tip of the iceberg, if you will, is very light, you know. So what has been exhibited at Bauma, that's the biggest, the big trade show in Munich in 2019, was the CC108 and CC112 generation. And also this system, the whole system weight was below 1 metric ton, right? Which is about 2,000 imperial pounds. And also CraftTrans, the latest publication and the latest product line we have developed for the DoD, has the same weight. Why is this important? Because apart from material, of course, it is important that the handling of the material, the deployment of the equipment, the redeployment of the equipment should be as easy as possible. And also, of course, the more sturdy, the more heavy such an equipment is, the more energy, the more equipment you need to transport it, to set it up, and so on. So, so Contour Crafting has always followed the path of having whatever they do, we do things that can be operated, deployed, and redeployed by a maximum of 2 persons. So ideally, once the crafter is operational, which typically takes between 15 minutes to 30 minutes in the case of CraftTrans, and about 90 minutes maximum in the case of CC108. That once such a crafter is operational, it only takes 1 person. Mm-hmm. And this person mainly has a monitoring task. This person is basically just looking whether the program is running without any problems, if material is coming, so we do not run out of printing material or other stuff. It's mainly monitoring, right?
So private individuals are able to purchase the CraftTrans printer now?
Excuse me?
Private individuals and companies are able to purchase the CraftTrans printer now, or it's only...
Absolutely, yes. So one, as you know, the military version has been delivered to the Army Corps of Engineers in December last year, which is only like 3 months ago. 2 are currently assembled for 2 orders, but we only make to order, basically. But we just recently published, you know, the information about the CraftTrans. And also we are providing and offering a civilian version. The civilian version will not be fixed on a flat rack like the military one with a standard pelletizing system as a system requirement, but it will be on a trailer so it can be pulled by any vehicle. And since the printer itself weighs a maximum of 1 metric ton, this is a very light thing, right? You just need to add the weight of the trailer, which is also not very considerable. So probably just a regular car easily can tow such a printer to any job site.
Mm-hmm.
And also, of course, energy consumption is a very decisive factor, right? Because the lighter a structure is, the less energy consumption is. Because naturally, if you print a given floor plan, whatever the layer height is in your specific case, of course, you need to run the floor plan many times in order to build the structure. And of course, you have a lot of acceleration and deacceleration in the process. And therefore, the heavier the whole thing is, the more energy you need to brake and to accelerate, right? So it makes all sense, I think.
So when do you think, how many years from now will we be moving from these one-off showcase projects to large-scale investment grade projects?
Do you refer to contour crafting specifically, or do you refer generally to the sector?
Whoever gets there first.
Okay. I mean, as I mentioned, I think the next step for contour crafting cooperation certainly is to get this so-called evaluation report on the basis of AC 509, because this is the door opener for each and every building authority globally, more or less. And this is the decisive step in order to open up the business as such, right? Of course, till then, and a lot of more machinery development by many different parties will be published, I'm sure. But I'm very convinced that Contour Crafting Corporation will keep its head start, which I think is a considerable head start in this sector. But of course, it is good to see other solutions around, because this enables, and only this enables, comparisons, you know?
Mm-hmm. It's hard to put any type of time estimate on it because it's kind of unpredictable.
It is kind of unpredictable. However, I don't think it's many years down the road. I think it can be as close as 1, 2. Let's be cautious and say 3 years from now. But I think it's sooner. It's going to be sooner, I think.
It makes sense that permitting would be one of the primary metrics you're judging that decision off of.
Yes, definitely, because, you know, it doesn't make any sense to produce a high volume of machinery if there is no building permit around, right?
Yeah.
What is a customer supposed to do with it if you only get single case permits, if you're lucky?
They can try to battle with their local municipalities, but it's much better to top down.
Of course, and it is done, and it has been done, and it will be done in the future. But it's a very tiresome process, of course, right? And fortunately, we have also this sector with the DoD, because the military, at least in the U.S., they don't need any civilian building permits, right? So on military territory or land, you can do whatever the military thinks sensible to do, right? Mm-hmm. So this is basically a very good solution especially for a time where civilian building permits cannot easily or in a standard process cannot be obtained.
Yeah, that's a great way to collect data and let the military be the loss leader.
Yeah, but you know, this is what the military, especially the U.S. military, has been doing for many decades, and very successfully, because they have, in many cases and technologies, they have taken the lead. They have paved the way. So we are very grateful that this is happening also in our sector. And it's actually a win-win situation, because it's for the DoD, it's a win situation, and obviously for us too, right?
Yeah, that's a great point. It's symbiotic.
Absolutely, and only win-win scenarios will prevail.
It also rhymes with, like you're saying, many other technologies, like some say the internet and like cell phone, whatever, different technologies. They say the government pioneers that kind of stuff, and then it's adopted by consumers many years later.
Absolutely.
Promising.
I think what really is the point I really wanted to make is that at the end of the day, only business models can be successful. Never technologies alone. Of course, technologies are increasingly a lead element in a potentially disruptive business model. But if the economic impact is not potentially disruptive in a positive way, it's not going to fly.
Initially, Contour Crafting had a vision of automating everything, like you said, electrical, plumbing, like the entire system. Is that still on the plate, or?
Absolutely. Absolutely. So we actually have decided, and that was also, I think, in August 2017, to not invent and create a robotic solution that encompasses 100% of the contour crafting abilities as published in 1994. We decided to realize this vision in 2 steps. Step 1 is 3D printing with concrete. We've done this. Of course, we will develop certain product lines, different product lines, also for different kind of houses in terms of buildings or structures in terms of floor plan and in terms of height. And the second will be the second generation or the second phase development will be to combine 3D printing with automation. But this automation, you know, actually is a two-sided sword, because first of all, you need to develop the function and integrate it into the robotic system, which at least Professor Krasnevis regards as not as difficult as the first development. The second part is, of course, that the realization of this vision also needs cooperation from other sectors, because as we speak, like piping, wiring, and everything else is now designed in a way that humans can install and operate it. Once a robot is doing it, of course, it will require a much higher degree of standardization and a certain way of standardization, because it has to be standardized in terms of lengths probably, and also in terms of joints, because a robotic system cannot put together and join things in many different ways. So there are certainly 1 or 2 ways which are most ideal, but I don't think this will be a big hurdle. Because those companies who are active in those domains and sectors, I'm sure that's at least my hitherto experience, they're very eager to be part of this development, because to them, it's an additional business, of course.
Yeah, there's a whole unexplored world of efficiencies that are the result of building for humans for so long, as opposed to preparing a building to be built by machines. Like,
right.
Of course, it won't be efficient to do it the same way it's been done historically. They'll have to come up with completely new ways to fully integrate these technologies, and really a bunch of technologies all at once. Because if you're going to be delivering a future house, a 3D printed house, it can't just be a 3D printed house with everything else completely regular inside. You're kind of selling the future. I think people are going to want like a smart house with maybe solar panels or something. They want the whole package at once.
Absolutely. And of course, let's be very frank here. Of course, this will mean, at least in a 3D construction printing environment, that a lot of jobs will not exist anymore. But this happens once a sector is automated. The same has happened to pretty much every other sector already. Just look at the agricultural sector, right? I mean, pretty much everything is machinery right now, right? Satellite data driven, you know. I think construction is probably one of the last sectors where this development, this general development, will be realized step by step.
Yeah, I don't picture construction jobs being taken away anytime soon, just because there's so many different types of buildings and styles and different tastes. And there's a shortage of labor, like people.
Absolutely, but that's the reason why I strictly refer to 3D construction printing. So my vision, or our joint vision actually, is that, we have stated this in our articles and publications so far, that we expect once the building code thing has been successfully ticked off, and this is just a matter of needs to be done, right? It's not a question for us, at least. once we have such a natural market, then I'm convinced that contour crafting will gain market shares in the residential building, in the commercial building sector, and definitely in disaster relief and social housing sectors. I don't see it in civil engineering, in civil construction, like dams or I don't know, as of now at least, right? I don't see it in high rises. High rises above taller than 400 meters, because it's a completely different art of constructing it. There is more steel in it than concrete because of those, loads and weights and heights, of course. But I really see that in residential and commercial building sectors, contour crafting or 3D construction printing, if we want to put it generally, will gain over time more and more market share.
You mentioned your approach to building a house is in sections as opposed to all at once. Does the printer move to each section and then print in place, or
No.
The sections are moved into place?
No, actually, the printer, each printer generation of Contour Crafting Corporation has a certain printing envelope, right? Whatever is within the given printing envelope can be printed in one shot, right? I will give an example. If you have a printer, for instance, that can cover a floor plan of 200 square meters, you can either print one house with having a floor plan of 200 square meters or 450 square meters attached houses, right? It depends on your design. But once this has been printed, you can easily relocate the printer and print the next 200 square meters. And that's the reason why the deployment and the weight of the system and the effort you need for such relocations and deployments is a very decisive factor, among others, of course.
And so the pieces are moved, they each weigh up to what, like a ton?
No, actually everything is printed on site, on the job site.
Okay, so the pieces are printed in place, and then
there are no pieces. The whole shell is printed directly at the job site in one shot.
Okay.
There are no pieces. There's just one structure, and the customer determines what the structure is, right? And of course, here you can profit from all the benefits of 3D printing, because 3D printing doesn't care whether it's curvy, whether you have rectangular structures or whatsoever. The printer doesn't care, because for the printer, complexity doesn't cost any extra dime.
What's your thought on finishing?
Well, finishing, ideally, and according to our experience so far, everything comes down at the end of the day to the surface quality of the printed structure, and of course, whether it is absolutely rectangular, right? The more you have overlaps, what can be seen in many videos, of course, the more finishing effort you have. We have a lot of patented printing heads, which provide actually a super smooth surface. So the finishing effort is not bigger than in any traditionally casted, for instance, wall.
That makes sense. The flatter you get it, the less material you need to use.
Absolutely, absolutely. And another factor, of course, is the layer height. I've seen many very narrow but wide layers. Of course, this means that you have to repeat the process very, very often, right? And in many, many cases, such tools follow just a given tool path, but not the wall structure. So the printing heads of Contour Crafting Corporation, with each and every pass, a whole structure piece layer is printed in one go.
And for designing printed pieces, printed models, is that something you're deeply involved in?
Well, personally not, but Contour Crafting Corporation definitely, because at the end of the day, it comes down to a slicing software, right? And also a clash check, basically, right? So this is one of the standard approaches that you have, of course, a digital layout, a CAD, a CAD file, for instance, and then it's uploaded in the system, and then it's checked, it's transformed into slicing through the slicing software, and then you see and check if everything is compatible or not. But at the end of the day, it's not really rocket science, but it needs to be done, of course. But that's part of the standard process. It can't be any different than that.
If someone listening is interested in buying the CraftTrans unit, how should they go about that?
Well, I have just recently posted on LinkedIn. There is one of our employees by the name of Sebastian Gomez, and he is responsible, or the point of contact for any sales. So it's sebastian.gomez@contourcrafting.com.
Terrific. All right. You are still the chairman of the board at Contour Crafting?
No, I'm not, because I've resigned as the CEO of Umdash Group Ventures recently. And since my function of the chairman was tied to the share, to the stake Umdash Group Ventures is holding, I had to resign. Barak was very unhappy about that, but that's just a logical step, a logical second step. And therefore, as I mentioned in the beginning of our podcast, is that as of now, I have promised to act as his personal advisor. Mm-hmm. So in our personal relationship, nothing has changed, and Barak doesn't really care what title I have.
Yeah, sure. And so, what are you focusing on now?
Well, as of now, I'm basically doing the same thing like I've done so far. So we tackle the problems he wants to discuss with me and gets my opinion on that, and then we move forward. However, it depends on what you mean with your question, but of course, everybody needs a bread and butter job. And this is something which is coming up soon, but it's still confidential.
Mm-hmm. Okay, cool.
But my plan is to remain engaged with Contour Crafting Corporation, and I've also promised this to Barak, and it's also my strong emotional feeling. I'm very much engaged with this company, of course.
Without going into too much detail, does your future confidential project have anything to do with construction?
Well, I could answer that, but I prefer not to answer it.
Fair enough. Fair enough. And all right, so we covered a lot of stuff here. I think it's been pretty insightful, definitely different from the other conversations I've had. You have a unique perspective on concrete for sure. Can you tell me about the precast concrete processing plant?
Of course, yeah. But before I do that, I would like to elaborate a little bit on other functionalities of Contour Crafting Corporation, because so far, or in the public perception, Contour Crafting is very much linked to construction only, which of course is true to some degree. However, Contour Crafting has also won two major prizes, NASA prizes, one in 2014, one in 2016. So Contour Crafting Corporation is still very engaged with also extraterrestrial construction, namely on Moon and Mars. And this is also for this, there is solutions available with at Contour Crafting Corporation, and also the cooperation with NASA is still going on, and I'm pretty optimistic that Contour Crafting Corporation will have a number of different divisions under the roof of Contour Crafting Corporation. One certainly will be terrestrial construction, if you will, and another one certainly extraterrestrial construction. There will be another one, hopefully, which is the exploitation of another patent, which has unfortunately been set aside so far, but just because of limited resources, which is called SSS. It's short for selective separation shaping, which is a patent that was actually the result of the second NASA award, which is a 3D construction printing technology, which is actually not limited to construction, but it can also be successfully applied with metals, for instance, or other materials. I think this will be another breakthrough in many other areas. Also, and unfortunately I cannot elaborate on that, Contour Crafting Corporation has developed also a certain printer generation for use cases outside of construction. So the technological scope of Contour Crafting Corporation is very large. Your question regarding those mobile, well, we call it portable precast plants. N3P, Neuland, that's the name of the company. Neuland, new land more or less, but it's a fusion in German, of the two German words, Neuland, new land. And we spell Neuland with DT because in German, Stadt, city, is spelled with DT. So in the vision is to transform new land into urban areas, basically, right? The concept of the Neuland portable precast plants is the following. This plant has been constructed and designed in a way that this plant is packed up in 40-foot standard sea freight containers. It can be shipped and transported to any given job site in the world. It should be a major job site. So we typically have projects running from a couple of hundred or to a couple of thousand units. It doesn't matter whether these units are like 50 square meter social homes or it is like high rises of 10 floors, for instance, or certain types of villas, but many, as long as it is highly standardized. But highly standardized could also mean that it's one or two different types of houses, but only those three types. And the N3P, once it arrives at the job site, is taken out of the containers, and about 4 weeks after having arrived at the job site, the factory is fully operational and can start production. And it produces right at the job site. So there's zero transportation, so no transportation cost, no time waste, no damages due to transportation. And of course, in many countries where the need for housing is the highest, typically there is a very weak street infrastructure or generally infrastructure. So transportation is a very costly and time-consuming and burdensome operation. So just being able to produce right at the job site is one extreme benefit. The second is that the project has direct access to the plant because this project is the only customer of this plant. And this plant is extremely productive. So each and every battery chamber is casting like 4 elements a day. Which is really the highest output I've ever seen. But the precondition is that everything is super standardized. It's a combination of a globally patented special formwork, which we call Butterfly, and a battery mold chamber, double chamber system. So it is very space efficient. It is also temporary because the idea is that this factory can be easily relocated once the job is done, because in about the same amount of time, so let's say about 4 to 6 weeks, it takes to put the factory back into the containers and the containers to the next job site. Mm-hmm. So this is, I think, a highly attractive, also economically very interesting solution, especially, but not only, to come to countries where the technology of precast is unknown or not available, or not available to a degree of the demand. So I think this is another thing that will help to ease problems in the world.
So you mentioned a battery operated chamber for developing the precast units.
Right.
How many shipping containers would one of those fit into?
Well, as I mentioned, the whole factory is packed up in 40 sea freight containers, and the factory is undividable, right? It's just a factory. You take the factory as a whole and put it there. And the number of chambers and batteries have been optimized by design, also by process design. So the process has been optimized in a given way. The only question the customer needs to decide is whether the plant is operated in 1 shift, 2 shift, 3 shift, or even 4 shift models, right? Of course, the most efficient way would be to have it being operated in a 4 shift model, which means that it's 24/7. Mm-hmm. That would be the European approach. In other regions, this is not really state of the art.
It's undividable. So no matter how big the building they're making is, it's 40 shipping containers.
Correct, because the size of the butterflies are standardized. They cannot be changed.
Very cool.
What must be changed is actually in the planning phase. So the buildings, the objects, the structures have to be optimized in terms of the separations to optimize the utility of the butterfly formworks. That's the main task in the beginning, but it's just something that needs to be done. It's not a real bottleneck or any real problem.
Do you know if they've published any video of their factory online?
We did, yes, on YouTube. You can find it.
Check that out. Okay, cool. I have some homework now.
Wonderful.
All right, so we can wrap it up, and maybe we'll do round 2 next time there's some big news from Contour Crafting to share.
Wonderful.
Great.
I'm here.
Thank you.
Thank you very much.
Enjoy the rest of your evening.
Thank you. Have a nice day.